All right, welcome everybody. This is session 2 with Salman, and we're gonna go ahead and get started because we got a lot to get through. I'll say a couple things first. If you have questions, you can post them in the chat, but we'll do like a Q&A after the presentation's done and everything. But I'll try to answer some questions in the chat. So if you have any questions, like I said, post them there. If you want to know about like, is this going to be watchable later? Yes, it is. Be on YouTube, LinkedIn, and then you can also, I think, watch it on StreamYard. But with that, let's go ahead and get started. So I'm going to hand it off to Salman, and then let's what you got to present, Salman. Well, welcome. Let's say welcome.
Oh, thank you so much, Mike, for the warm welcome. I appreciate that. I'm glad to be here. Super happy. So
just
we
peace
can
out
get
immediately.
started.
Yeah.
Yeah,
Right,
absolutely. Yeah, thanks. Thanks for the quick intro there. Awesome. All right, cheers, Mike. Welcome everybody. Thank you so much for joining. I know this is the whole series we're doing with Loft, and there's like 6 sessions, and this is another part. And today I'm going to be talking to you about standardizing dev environments in large-scale multi-tenant Kubernetes clusters. Take a deep breath. I know that's a lot of buzzwords, but what does it actually mean? I'm going to pose a question first, then we'll do the intros, then we'll go into the topic. But let me start with a question, just so we all know what we're here for. Imagine you have development teams, and they need to develop their apps, test them, release them, etc. You can perhaps, because we're talking about Kubernetes here, you can perhaps give them a cluster each. Imagine you don't just have one team, you'll have plenty of teams, maybe a 4, 8, 12, 16. You might have many teams. If you start giving everybody a cluster to do what they need to do, then potentially this could end up being very expensive, and there's a lot of overhead. We're going to talk about overhead later on as well. An alternative, perhaps, is to have fewer clusters and share them across the teams, i.e. multi-tenancy, right? That's what the multi-tenancy is. So this could potentially be a cheaper option or cheaper solution, and that could meet your requirement. And this option, though, has its own challenges around security, around isolation. How do we onboard people? So the purpose of this talk that we're going to do for the next 40 minutes or so is to answer what options are available to us for this multi-tenancy if we have to do onboard teams, multiple teams on a single cluster or multiple clusters. And look at these options, and I'm going to present to you 4 options, and we'll look at the cost and complexity of those options in terms of how easy it is for us to bootstrap the infrastructure and onboard the teams that we need to, how easy or difficult or complicated it is to maintain it, and in the end, how you can easily upgrade them. So these 4 options, as you can see, option A, B, C, and D, these are, I'm not going to reveal what these are. You will have to watch at the end. You can see option D perhaps is the most expensive and the most complicated one. But then I'm going to present you these options, including some real use cases where you can see what the other organizations are doing, so you can perhaps learn from that. In the chat, if you'd like to just drop any comments, like where you signing in from, that'll be cool to see. Just say hi. If you have any questions anytime, please drop them in the Q&A section, and we will answer all the questions at the very end when we finish up. Anyway, so that is what this meant. So standardizing dev environments, we're going to focus on like non-production environments, because we hear a lot about production environments, so we'll come to that in a second. So especially if you have a big team, if you have a lot of engineers, you need a lot of infrastructure, and also if you need to be able to run multiple teams on the same cluster. My name is Salman Iqbal, and I am an instructor at Learn K8. So we do training all on Kubernetes. So things like this we cover in our course. Please do check out our website, learnk8.io, if you're interested in learning further about Kubernetes. We also have a bunch of blogs, and you can find us online. And we are this is the second year that we're collaborating with Loft. But yeah, I also do DevOps and MLOps as a consultant. You can find me on Twitter, and I do have a YouTube channel, which I haven't uploaded to in a little while, but I might drop in some videos pretty soon. But before I go any further, I just want to say massive thanks to Loft for having us, especially Mike and Rahul. They've got us for the whole series, so we've got some excellent topics with us. Daniele already did one topic before. I'll recommend you. I'll talk about that briefly. If you haven't checked it out, please do check it out. So thank you, Mike, for hosting us and having us here. Before I start, I do want to give a massive shout out to Daniele who did the first session. He helped me put together this. We were having a discussion about what we need to talk about and how we're going to do it. So we bounced off some ideas. So he helped me put together this talk. So thank you, Daniele, for that so much. Anyway, that is out of the way. So we know what we're here for. And what we want is multi-tenancy. Because we, as you can see, as I briefly mentioned to you, if you give everybody a cluster, is going to become a bit expensive and managing will become a little bit hard. So if I do want a multi-tenant environment, let's just bring our requirements up front, right? Let's just define what our requirements are. We want to minimize computing overhead. And, there's a few other things that we need to see. So as a cluster is going to be shared by various teams, we want to make sure that we can isolate workloads from one to the other. So if I have team A, then the workload is running in the same cluster as team B, and in Kubernetes by default, every pod can talk to every pod. That is a little bit of an issue. So how can we get the isolation, and how can we implement the security best practices? So this is one of our requirements. We need good isolation if we do put multiple teams on it, and we need to be able to manage all of these things correctly. When I talk about management, I'm talking about bootstrapping. How do I set the initial setup up? How do I get the teams on? And how do I install the tools that I need to install so that it's standardized for everybody across the whole cluster, across the whole estate that you're using, right? So I need to be able to manage it easily. And of course, for sure, I don't want to spend a lot of money. This is non-production environment, and as you'll see in a little bit, you actually end up with a lot more non-production environments. I'm sure that's the case for you guys, for you all as well. We also want, basically, we want to save some money. We don't want to do it so that's very expensive. So how do we realize this multi-tenancy dream inside Kubernetes? These things and Kubernetes, how can we do that? Well, let's take one step back for a minute so we're all on the same page. Here's the thing. Kubernetes embraces the idea of treating your servers as a single unit. No matter how many servers are running under your Kubernetes clusters, how many worker nodes you treat Kubernetes as an API. You submit a request to Kubernetes and Kubernetes deploys it. So for us, it seems like it's just a single cluster. Imagine you have 3 servers, let's say in this case, and I make one of them the control plane. I install Kubernetes on one of them. So that becomes the control plane, and the others are the worker nodes. And then if I need to deploy my application inside a pod, I submit the request to Kubernetes. And Kubernetes abstracts away how many worker nodes are running. At no point does a developer need to go in and check, well, how many nodes are running. I just submit a request to Kubernetes, or the pipeline submits a request to Kubernetes, and it deploys the pod that it needs to. And then what Kubernetes does, it goes through the whole process, takes your configuration, starts a pod inside your Kubernetes cluster, and the pod that includes a container, multiple containers, and it'll execute Docker and basically start it. And then you can keep deploying as many as you like, and they all get deployed. But in reality, what actually happens, as you're all aware, is that, well, Kubernetes has a component called the scheduler that figures out where to place these pods, right? It'll say, okay, I'll put these pods in this node, put these pods in that node, depending on the requirement of that pod itself. So you'll basically distribute the pod across the infrastructure. Now, one of the resources that comes out of the box in Kubernetes, just like a deployment, just like a service, just like a config map, is called a namespace. And imagine you have 3 applications and they belong to 3 different teams, let's say, right? So the red one, the yellow one, and the green one, well, they could have multiple components inside, doesn't matter. They have a pod, they have a config map, they have a secret, they have a service, they have an ingress, they have these resources they need to deploy to the cluster. So you could you need to compartmentalize them, maybe just put in you need to compartmentalize them in a single place. So you could create what's known as a Kubernetes namespace. And you can place all of these things inside a namespace. And you might think that namespaces, perhaps, maybe it refers to a lower level implementation of the kernel, like a kernel namespace. And then it might provide some isolation. But the reality is that namespaces is just a logical partition of the cluster. And all we do is we use it to group objects together. It doesn't offer any isolation. It's just a convenient way for us to categorize and compartmentalize objects. So So I can create a namespace. I can give a namespace to a team. I can give a namespace to a cluster, to an application, and then you can deploy these things in here. And when you deploy it inside a cluster across different namespaces, nobody's going to get any isolation by default. So if you deploy multiple teams in the cluster, isolation is a bit terrible. So what can we do there? But before I go ahead, let me just quickly show you. If I don't show a YAML file in a Kubernetes talk, then is it really a Kubernetes talk? So that's the first YAML file. That's the YAML file counter. Do that. That's the simplest YAML file I'm going to show you today. And that is a namespace. If I want to create a namespace, I can just do that, submit it to the cluster, kubectl apply -f, and I end up getting a namespace, right? And I can create as many as we like. So let's start with the namespace, because we said namespace help us compartmentalize things. Cool. But they don't give us any isolation. So maybe we can take the namespaces, perhaps we can apply some things on top and then get what we want. So namespaces, a good starting point, right? Because there's really no overhead. If I want to create it, all I do is write a YAML file, say this is the namespace I need, and I submit it. But how do I carve up a cluster? Let's say you have 3 teams, right? And you want to split this up by 3 different teams. The cluster, you want to split it by 3 different teams, team A, team B, team C. Or perhaps, this is just an example, right? Or perhaps maybe you want to carve it up by dev and test and staging, right? So the idea here is you can carve up the cluster however you want. You can do it by teams, you can do it by types of environments, or you can have a mixture of both. Whatever you want to do, this is what tenant that's what a tenant means, right? It's a different set of entities that want to use that environment. But of course, Team A, if I go with just Team A, let's say, Team A will need multiple environments because they need an environment to do the development, they need to do some testing and staging. And same, Team B will ask for the same, Team C will ask for, they have their own requirements. Somebody might need like a pre-prod environment, or somebody might need like a hotfix environment. So, everybody has different requests for environments. When you're operating at scale, if multiple teams request these environments, then you can imagine that this diagram will start to look a little bit more busy than it actually is. Right now, you only have 9 environments. You might think, not a big deal. Imagine you have hundreds of teams, and you'll see that in a minute. And that will become very, maybe a bit expensive. So let's talk about scale for a moment, right? Let's talk about scale. Because this is all about scale, right? So we said we're going to standardize development environments on scale. So not only you need test environments, and you can also see at the bottom of this slide, you will also require a production environment for any of these systems, right? All these systems require production environment. So imagine for a second, I'm going to separate out, like in this case, you have a cluster for each environment, right? Team A has a dev cluster, team B has a dev cluster, and all the way down, production also has a dev cluster. But before I go any further, if you look at this diagram, what you realize is that the non-production environments are 3 times the size of the production environments, which is a little bit costly, right? Because I know, yes, in most cases, the non-production environments are not going to be the same size as the production environments, but they will be there. They have to be there. You have to use them. So, that's a lot of environments that we need. But don't take my word for it, right? Don't take my word for it. Let's make it real for a moment. I don't know if you come across this Cube FM podcast. I'm definitely not biased, but the best Kubernetes podcast is Cube FM. You should definitely check it out. Type on internet Cube FM. It's hosted by Bart Peter Pan Farrell. Shout out to Bart, and Daniela does a lot of work on it. They got a lot of great guests on the Cube FM talk. It's all about, our podcast is all about Kubernetes, and they talk about their real use cases and how they're implementing at scale or whatever challenges they come across. There's a lot of talks on there. Definitely should check it out on podcast, Spotify, all of the places. So one of them, and I personally learned a lot of them. One of the guests is Alexandre. He's from Getter's online grocery delivery company. And what he mentions is that he talks about scale. And he says on the platform that he's working on at Getter, they have over 1,000 developers. And they're working on various services. And they require development and production environments. And you see the way they use their infrastructure they have about 150 development namespaces and about 46 production namespaces. So you can already see what I told you before, the production instances, like the non-production instances that you have, are almost 3 times the size of the production instances. And same for workloads. Workloads here means like microservices, right? We're not talking about pods here, just talk about workloads as microservices, a bunch of different things. And that is also almost the 3 times size of that, right? So, and when it comes to production as well, they also can scale up at times of high load up to like 9K. But anyway, so if you are operating at scale, what you'll see is that the cost and management of your non-production environment is equally as important as the production environment. I know we always talk about is your production environment secure, but non-production environment is also important. So we talked about scale, right? So that was scale. Let's look at the next part, which is the isolation, especially when it comes to multi-tenancy. Let's say we have 10 different applications, or 10 different tenants. Let's just call them tenants. And they don't necessarily need to belong to one team. They could belong to multiple teams, or multiple teams could be developing the same app, or whatever it might be. So the thing with multi-tenancy is that they all might require some components. In this case, I'm showing you an example of an ingress. Let's say all the applications that are running the clusters are a website, and the traffic then needs to be routed from outside of the cluster to inside the cluster. And they all need an ingress controller. If they need an ingress controller, you have 2 options. One, if you have those tenants, all of those tenants running inside, this is an example, by the way. You have dev, test, and product. We just put in one slide just to give you a flavor. If all of them share an ingress controller, then you can just run one ingress controller, because the request from outside the cluster goes to the ingress controller pod, and the ingress controller pod routes it to the right pod that it needs to go. So if there's one ingress controller running, that's fine. You can submit the request, it will take it and do forward. But if you have an ingress controller running for each of those instances of applications that are running in the cluster, basically I might end up running a lot of pods in the cluster. What does that mean? Well, there's cost implications for it. If I were to run one ingress controller, if you look at the ingress Helm chart, the ingress Helm chart says that the amount of requests of CPU and memory is here 100 megabytes of 90 megabytes of memory, 100 millicores. So this is some space I need to have in the cluster so I can run it. No problem. One ingress controller sounds good. If I were to run 30 ingress controllers in my cluster, that is sizable. So I need about 3 virtual CPUs and about 2.7 gigabyte of memory. That basically is the size of a small node in a Kubernetes cluster. So that's something that you need to think about, right? So if we are sharing resources, if you are sharing a cluster, maybe we can share some of these resources. So what about security, right? We talked about scaling. We talked about isolation. Let's talk about security. So we've talked about these things, we're going to share it if we need to. So let's explore how you can do this with zero overhead, like the security. Imagine I have a namespace and I deploy the namespace in the cluster, and I tell one team you can deploy your applications inside the cluster. They deploy in the cluster, and then something happens and there is a vulnerability in the application, and somebody tries to the vulnerability in the application is inside one of the given pods, and someone gets access to the application. They exploit the vulnerability and escape the container, because you can escape the container. There should be a cross on the slide. I'm not sure what happened there, but that box should be a cross. And after escaping the container, they could get hold of the node the pod is running on, and they can control the kubelet. And kubelet is the bit that talks to the control plane. So they could escalate and get hold of the control plane. So the more applications run in the cluster, the higher the chance of vulnerability that could be exploited. So that's not good. That's something that's definitely we don't want that to happen in production, right? We don't want that to happen. And I mean, our setup should always be secure, but in our dev environments, we don't have the production data. So perhaps the risk that an application could have an exploitable vulnerability might be acceptable, as long as you do all the other things. You have your scanning tools that are running. So but what we do see is if I start sharing the environments, I can perhaps start to save some money. So what we're going to check is, what we're going to see what we're going to talk about is non-production environments. So I'm going to leave the production environments to the side a little bit. So what do we want from our non-production environments, right? We want to keep the cost low. And when we do have to do the setup or onboard a team or a tenant, the setup is of low complexity. And what we really want is standardization, or as we can call it, governance. This is more than just security. It's a bit more than just security because we want to do things in development environment in a standardized way, especially if we're working at scale. If we don't have standardized ways, different teams are going to be doing different things. If we need to deploy a tool, if we need to do a deployment, we do it in the same way. If we use a tool, we all use a similar tool in a standardized way. So we are going to look at now these 3 points in terms of cost, complexity, and governance, as we talked about at the very beginning, and see what we can do. Now, let's start with managing our costs. So now what you see is a shared cluster versus dedicated resources. That's what we're going to do in the next 5-10 minutes. We're just going to see how it goes. Imagine if I have all these tenants and they all need their own dedicated ingress, the cost is going to increase. As I showed you before, the more components I install in the cluster for things to operate, I need more space, I need more CPU, and I need more RAM. That means that's just money I have to pay. So that's going to be expensive. But if I were to be able to share some components, I'm giving an example of ingress, but you could use things like service mesh, like Istio, or logging and monitoring tools like Prometheus or Grafana. If I can share, my cost is not going to be as much as what it was before. Let's explore another thing. One thing we would like doing with Kubernetes is worker node utilization. If the node is empty, really, maybe we should scale it down, because we don't need that node anymore, right? Let's just scale it down. So imagine you have one cluster with multiple worker nodes, in this case. Some pods belong to one tenant or the other tenant, whatever it is, but imagine this one belongs to one team, the one that you're seeing in your diagram up front. Inside the cluster, there's one scheduler, and the scheduler decides where to deploy these pods. So the scheduler receives the request, and what it will do, it'll figure out, yeah, okay, I can put this on this node, and I can put it on that node. But in this case, the scheduler is just doing scheduling for, like it's basically across the worker nodes is doing the scheduling, right? So it's in one cluster is doing the scheduling. But on the other hand, if I have two separate clusters, right? Two separate clusters that belong to two different teams, overall, in your overall resources, the scheduler is just going to do it at cluster level, right? Because it only belongs to one team. So I might end up with some nodes which are running only a few resources, right? So that's kind of not great. So we saw scheduling, how Kubernetes does it. Let's look at node utilization from another point of view, right? Depending on the availability of your nodes, when you try and schedule the pod in your cluster itself, Kubernetes finds the best fit for the pod and deploys on the cluster. So you can run what's known as a descheduler in the cluster. Because what happens is, in this case, you can see the problem here is most of the pods have been deployed to one node, and the other node is almost empty. And that is a bit of a problem, because one node is a single point of failure. If that goes down, we lose everything. So we could run what's known as a descheduler. And what the descheduler will do, you can run it as a job inside the pod. It's a project from Special Interest Group in Kubernetes. You can search for it online. There's a GitHub page for it. And it will run in the cluster. And it will delete the pods. It will delete the pods, and it'll try to influence the scheduler, because the pods that get deleted will have to get rescheduled again with the Kubernetes scheduler. And when it comes around, it will make sure it places them in the right way. So and then because it runs as a cron job, it disappears. So what we can do with this case is, these scheduler will influence, and if you have a cluster and an autoscaler as well that sits on top of the cluster, it could add or decrease the number of schedulers, right? So, but if you're sharing the cluster with multiple worker nodes, this is going to work well for you, right? The descheduler will work well for you because it's doing it at a higher level. However, if you have multiple clusters for different teams, this is not as effective. Yes, it would rebalance inside the cluster, but it won't do an overall rebalancing, right, of all the workloads across everywhere. So if you have separate clusters, perhaps not as effective as if we have clusters or a couple of clusters that are shared across multiple teams. Hope you're with me. By the way, if you have any questions, please feel free to keep adding them and we'll answer them at the end as well. And Mike, as he's going along, he's going to be answering some questions too. So what do we have so far? Well, what we talked about is we can share components like the ingress, and we can share the infrastructure. I just talked about right now, right? You can share the infrastructure, you can deploy teams, you can create namespaces, you can deploy them on there. And hopefully you can save money as you're sharing infrastructure and components, right? So hopefully you can say that. So far, let's take stock of where we are. What we want is the non-part environments to be of low cost. And we just saw how that's possible. Share the resources, share the infrastructure, share the, run components which all the teams can use. You can do that. So that's low cost. Let's go into the next topic, low complexity. Let's explore the complexity. What are the areas that we need to consider when it comes to it? The first one is bootstrapping. What do I need to do to onboard a team onto a tenant? Let's have a look. Remember in the beginning, I mentioned that you can create a namespace. And we saw how it was simple, how that was possible. So we can create a namespace for team A, I can create a namespace for team B, and I can tell, hey, every time you do a deployment, all you need to do is, I'll just create one cluster. All you need to do is in your deployment files, just reference the namespace. Or if you do with Helm, you don't just send it to a specific namespace. When you apply, just do it to the namespace. So that is low effort, right? I just need to create a namespace and let people know. On the other hand, imagine I create a cluster per team. Every team, every environment gets a cluster. I get 1, 2, 3 clusters, 4 clusters. If I have multiple clusters, I don't want to standardize what's happening inside the clusters everywhere. I need to be able to have like a management cluster, right? I need to have a management cluster so I can install things like add-ons that standardized across all the environments, like some observability, governance, authentication, etc. That's basically I need to have that. And then I need to be able to have some pipelines to deploy things, or have deploy things across to all the deploy applications, deploy configurations, deploy any of the plugins that you want to install across as well. So perhaps I need to create some pipelines. Maybe I'm going to do Argo CD. Maybe I have GitHub Actions, CI/CD pipelines. I need to be able to do all of that, right? So if I were to have dedicated clusters for the team, a little bit more complicated because I have to have a management cluster. I have to do that, but that's something that to consider. Now, that was bootstrapping. Namespaces inside a cluster, you can bootstrap a couple of clusters and share them. A little bit simpler, and I'll bring it all together in a minute. And then also, if I were to deploy multiple clusters for the teams, it's a little bit more complicated. So let's have a look at when things go wrong, right? So here's a little bit. Imagine you're sharing a namespace in a cluster. Node goes down. A node goes down. It could impact multiple teams, right? Fair enough. Not that great, but it could impact multiple teams. But there's a few things you can do. Make sure the pods can get rescheduled on other spaces and whatnot. Versus if everybody had their own cluster, one of the node went down, then yes, only the team that cluster belongs to will impact them, right? So in this case, perhaps the individual clusters are a little bit better. Now let's talk about, this is one of my favorite topics, upgrades. Imagine you have 2 tenants inside a cluster, 2 different teams, and their apps are running absolutely fine. And at the moment, they have a shared cluster and it's running on 131 version, Kubernetes 131. Everyone's happily running everything on 131. So you tell the teams, you need to check if your things are going to run on 132. Can you have a look at what impact does it have? So that one of the teams says, yeah, we're ready for 132 because we need to upgrade to 132. The other team says, actually, we're not really ready, right? Because it's quite tricky. We need to do some upgrades on our application. We don't really have time. We're working on something else. We can't really change a configuration file. So when you come to share the infrastructure, that maintenance could become a little bit tricky. But so that's a little bit of a complication. So if you share a cluster, you can easily create a namespace and you can house multiple teams. That's fine. It's simpler to create the namespace and then to create a cluster. I hope you agree with me. Additionally, you don't have to manage components across the cluster, across multiple clusters. You only manage across maybe a couple of clusters. The only thing is when it comes to updates, it's better to always do incremental updates rather than jumping from version 130 to 135. Because big jumps do bring in a lot of breaking changes, sometimes can bring in breaking changes, and often can be disruptive. It's kind of hard to do. So incrementally, if you keep doing incremental updates, that could help a little bit. So again, let's take a stock of where we are. What we wanted was low cost. How do we get low cost? Well, shared resources, shared components, low complexity. Okay, cool. Namespaces. I can, create namespaces, get people deployed on. Yes, there's a big complication on if multiple people, multiple tenants are sharing the namespace, then they have to be able to upgrade together, and nodes can go down and whatnot, whatever that might be. So let's have a look at the last requirement for a non-production environment. And then I'm going to present you the 4 options, and then we'll talk about use cases, and then we'll be done. I know we're halfway in. I hope you all with me so far, all having a good time. Yeah, please keep adding your in the chat how it's all going, and yeah, let's keep going. Cool. I can see a lot of comments there. Cool. Now let's continue. Talk about security. I'm not going to call it security because we want something a bit more than security. We want governance, right? Because we want to be able to do things like this. What we want is, imagine you have a cluster that's being shared by various teams, and you might want to restrict access to resources, such as pods from one tenant not being able to be accessible from other tenant, or people being able to create different types of resources. And we want to prevent mistakes from being happening. Somebody deleted something by mistakes. But more importantly, what we really want is to promote best practices across the whole organization. And we want to be done in a standardized way. If you want to install a specific tool, hey, here's a standard way of doing it. If you want to install a specific observability tool, that's what it is. So when we talk about governance, it's just a bit more than just security. It's how do we get best practices instilled across the whole space. So let's have a look at each of them one by one really quickly. I'm going to show how do we get restricted access, right? So how do we implement access, as in how do we enforce good practices? So in Kubernetes, when you submit a request to the cluster to deploy anything, it goes via a component called the API server. And usually you see the diagram of the API server that looks like this. But the API server itself is made up of multiple components. Somebody's trying to create a resource, is made of multiple components. And one of the components in here is an validation admissions controller. Every time you submit something, it checks if what you're submitting is actually valid, right? Valid according to Kubernetes rules. But you could define your own specific rules on a valid configuration. If somebody tries to pull an image from a registry that you don't know, that is invalid for you. So you can use a webhook in this validations admissions controller to restrict that from happening. You can install a third-party tool. I'm sure you come across Open Policy Agent, Kyverno, Kubewarden, and you can define these policies. So when people submit their request, if it doesn't conform to the rules that you've written, they get rejected. It does not get deployed to the cluster, and of course they get told. So what kind of things we can do? Okay, we can set labels consistently. You can allow administrators to set constraints on total number of resources, resource usage per namespace, and you can make sure that the pods, again, this is best practice we want, the pods are defining the requests and limits so they get deployed correctly. And things like, I'm just giving you some examples, and making sure that people stop pulling from resources from container registries they should not be pulling. So let's take a stock of where we are. We said if we wanted to create a non-production environment, share it across teams, we want it to be low cost. So we saw that earlier on. We want it low complexity. Namespaces we can onboard easily. Okay, there's some complications in terms of like debugging when things go wrong. And then we want some really high governance. We need to promote best practices in terms of security and everything else in order to have less complex setup. Hope everybody's with me so far. This is now going to get into a little bit more meaty. What about quality control, right? So I mentioned a couple of things. Let's promote best practices, right? High governance, everybody's following it. How do we keep an eye on things? How do we make sure that people are still doing, you can define the validation rules, you can define this and you can define that, but things change all the time. How do we keep an eye on things? Well, what you can do is you can install some tools in the cluster. For example, there's a pretty cool tool called Popeye. It's a utility that scans the Kubernetes clusters and it reports potential issues with deployed resources and configurations of the cluster and resources that have been deployed. and you can install it into the cluster and point it to your cluster, and it will give you a tool. It will give you a report that will say, it will show you, oh, these pods are running as privileged. They should not be running as privileged. So you'll get that report. And again, that's not the only tool. There's a bunch of other tools that you can use. So you have kube-conform. It's a manifest validation tool. So you can scan a YAML file, so you can incorporate that into your CI/CD pipeline, CI pipeline, or you can run it locally. You can validate your Kubernetes configuration according to this, the things that they have. It's the best practices that I have. And kubelinter, again, similar thing. Checks against a variety of best practices for Helm charts and YAML files, and it focuses on production readiness. This is an output of like Popeye. This is what it will give you to enforce quality control. So that's what this is for. Now, let's have a look at this. I've been talking about standardization. Let's standardize what we're doing. Let's standardize what we're doing. I don't want you to take my word for it. I want you to hear from Angel, who was on Cube FM, and Bart, who's one of the hosts of the podcast, interviewed him. He's from Adidas. He's a senior platform engineer, Angel. And what he's talking about, he's worked at scale with Kubernetes. They have about 1,000 engineers, and they have about 100 clusters that working across, right, and 4 regions. But that's what they're doing at scale. But one of the things that stood out to me in this podcast is that when working at scale, Angel said the best thing for them to do was when they had standards, everything just became much easier. Onboarding, running, debugging, they just defined standards. For example, they said everybody was going to get Grafana dashboards, and they're going to have integrated audit logs. Anybody does something, it gets audited. And everybody will have a single pane of view. Everyone can see what's happening in their cluster, in their application. But what he was across all the two, you saw there was 100 clusters, right? That's the standardization. That's important. Standardization is important because that's how Adidas do it at scale. So I've been telling you about multi-tenancy is good, right? I can share it for non-production environments. I can get a non-production environment. We can share it. Yeah, we have some challenges, but there's some good benefits for it. But you might ask me, how do I do this multi-tenancy? Well, let me present to you what Daniele Polencic, the legend himself, presented in the very first webinar. What you have is a scale of multi-tenancy. On the very left, we have namespaces for multi-tenancy. So the left is, and on the very right, you have dedicated clusters, right? So we're going from one to the other, one extreme, one side to the other side. So the left one says, have a cluster, share it across the teams with namespaces. And the right one says, here, give everybody a separate cluster. And actually, Daniele did a great overview. He compared some of these tools, and he said which one's good, which one's not. And, he did evaluation, like he said, he gave criterias on which is the strategy that you should go for when you pick it. He did a comparison between Capsule, KCP, K3K, and stuff like this. Definitely check out the previous tool. But what I'm going to focus on for the next 5 minutes is the part on the left-hand side of this diagram. As we said, dedicated clusters, very expensive. We don't really want that for non-production environment, right? So we're going to talk about the very left here, and we're going to go all the way up to, these are the light, I call them the lighter options here. We're going to go all the way up to control plane as a service, and vCluster is there at the end, right? And we'll talk about that in a minute. One of the things I do want to point out is that CRD, custom resource definitions, are global. They're not namespace bound. So if you wanted to have isolation for CRDs, of course, the CRDs, you can isolate them in separate cluster itself. I just want to point out vCluster, which is a tool which we're going to talk about in a minute, hopefully you're already aware of, is quite good at CRD isolation, right? So this is really, this area that you see that's been highlighted is all about CRD isolation. But we're not going to focus on custom resource definitions. Things like if you need to isolate just, I deploy Istio and it should only be used in only one namespace. We're not going to focus on that. That's what it is. So I'll start with namespaces, then we go namespace service, and then these are the 4 options we are going to compare, and it will tell you which one might be good for you. Right, so let's go. Let's start with vanilla namespaces. I can have a bunch of clusters. I can have a cluster, and I'm not sure what happened to the dash boxes. I'll fix that later. But what we want is we can define a cluster. and we can give different namespaces, and we can get different people to deploy resources inside the namespace, right? Cool. There's just a namespace, people can deploy stuff. But namespace is not enough on its own. So I can define what's known as a resource quota that constrains, basically provides a constraint and limits how much resources can be deployed inside a namespace. How many number of pods, how much CPU, how much memory. Because I don't want people to just run whatever, we want to restrict what they're running. And we can define these as we don't want other tenants to be able to be starved of resources. And then I can also define limit range in Kubernetes. A limit ranges restricts the consumption of CPU and memory of pods and containers within a namespace. Basically, it helps prevent individual workloads that are running in the cluster from consuming excessive cluster resources. So I can define that. And remember, I said in the beginning, every pod can talk to every pod. Well, what we can do is we don't want the pods to be able to talk to all the pods. So I can define a Kubernetes resource called a network policy that allows me to define the rules. This is almost like a firewall, define the rules of which pods or which namespaces can talk to each other. So if I create a namespace, I don't just create a namespace, I need to do a bunch of these things. And you can also do pod security admission. It used to be, this is replace pod security policies, so it's called pod security standards. But you can enable this in a namespace, and it applies best practices like security workloads. For security workloads, stop running as root, block net admin, and all things like that. So basically, we can apply when somebody tries to submit a resource, it will reject it. So if I just do a namespace on its own, I need to go in and give all these things. I need to configure all these things. So I have something that is a bit more tangible and that's a bit more, let's say, secure, right, to start with. But the thing is, that is a bit hard to do. And not hard to do. You have to spend some time in identifying what you need to do and apply all those things. Maybe we can do a little bit better. So why don't we just have a namespace as a service? So let somebody else give me a namespace and apply all this governance that I'm applying around that namespace. Luckily for us, there's a tool called Capsule, which is on that bar that you saw earlier. The Capsule, you're deployed in the cluster, it runs as a controller, and that basically applies all the things that we've seen. It applies network and security policies, resource quota, limit ranges, even RBAC. So the owner at the top is like even RBAC, and the users can do whatever they need to do inside their own tenant, right? A tenant is a type of resource for Capsule, which basically creates a namespace, including a bunch of these things that we wanted. So you don't have to create the namespace and apply everything itself. You just define a tenant. And it also it defines the limits of how much you can run, how many pods you want to run, and also provides a user who can own this tenant itself. So basically, what we get is namespace as a service. So let's go to the third option. Now we're cooking, right? Now we're cooking. We're getting somewhere. We got namespaces. We can apply some controls, and then on top of it, we can have also namespace as a service. Cool. Can we do any better? Because we're still inside the same cluster. Maybe I can perhaps treat this as separate clusters. What can I do? Let's say I do this. I create a namespace in the cluster, and I deploy K3s. This is a lightweight Kubernetes distribution that by default uses SQLite instead of etcd. And it runs as a single binary, and it's just a regular pod. Right, and you can hit the APIs. Basically, it's a Kubernetes cluster running inside. You can hit the API server of this pod. This is Kubernetes itself, runs inside a pod, and you can submit workloads to it. And there's basically no nodes for it, just the pod that's running. If you look into it, all it has the pods inside. Like it has the API itself inside. But it's got its own etcd as well. Now, the idea here is that when people deploy resources, what you can do is you can define your own cluster, your own virtual cluster within the cluster. This is where I'm going to talk about vCluster. You define your own virtual cluster within the cluster. When people want to deploy anything, they deploy to the virtual cluster directly in the API, right? Not to the control plane API, but they deploy it on there. But this API, as you see, has no nodes. Which API has nodes? Well, this API has nodes. So if you submit request here, this doesn't have nodes. How is it going to place the pods? Well, here's the thing. This is what actually happens. What we want to do, if somebody submits a request, we want to copy the spec of something that we need to create and put it inside the main control plane so you can create the things that I need for my own cluster. And then magically the pod would appear. And this is the job done by a virtual cluster. There's a component called syncer, and you select the resources and you direct this and basically syncs between them. So if you wanted to create multiple clusters, this will apply those things, right? So you can install vCluster on your cluster, you can define multiple cluster inside, and then people can operate inside a cluster. So all the things that we've shown you before, the restrictions, the quotas, and everything, they behave inside a cluster like it's just one cluster. So that's kind of good. So we're improving our security posture and also our isolation more and more and more. So this is basically people don't even know that they're talking to a virtual cluster that's running inside the pod, inside the cluster itself. Of course, when you install an extra pod that's running the cluster, when the syncer runs inside the cluster and the K3s runs in the cluster, it adds a bit of memory and CPU, right? So there's a little bit of an overhead, which I'm going to talk about in a second. For completeness sake, to end it, what we're going to talk about is dedicated clusters. If I have dedicated clusters, yeah, I have team A, team B, team C, everybody has a cluster. Then if I need to deploy shared components across everywhere, I have to apply it via management cluster, and then the shared components can get deployed. And then if anybody wanted to deploy their own applications, they have to go across and deploy everywhere. Right, now this is a little bit tricky because you have to, not tricky, is good, isolation is good, but you have to create them all. So let's compare 4 of these options. Now this is the comparison and quick case studies, and then we'll take some questions and then we'll finish up. So cost plus complexity on the y-axis and 4 different options on the x-axis. If I want to create a namespace, a vanilla namespace, quite easy. Bootstrapping, simple forward, I can just create that, no problem whatsoever, YAML file. Opinionated cluster, so Capsule is basically an opinionated control plane, a controller, that will going to create me a namespace and a bunch of other things. But you saw the YAML file, kind of straightforward, just define a tenant and it will create it. vCluster takes up some resource, but is good because it's going to isolate, basically create a cluster in itself. But it'll take up some resources, so there's a bit of cost there. Dedicated, right? It'll take long to provision it, and of course, it's going to cost a bit more money, right? So bootstrapping, that's what we have. Let's continue. Maintenance. Well, you might have to update the quotas and stuff like that. That's fine, but it's a namespaces Kubernetes resource, so we don't really have to worry about that too much. What about you might, if you have Capsule, you might want to understand how the controller works, because if it breaks, you have to figure out how to fix it and manage it. And you need to be able to understand in vCluster if something goes wrong with a syncer, if you need to debug any of these issues. So there is a bit of maintenance, and you have to update these Capsule. You have to update vCluster version that you're running. So a bit of maintenance there. And yeah, I mean, good luck with the last one. If you have multiple clusters, you have to upgrade them all. You need to be an expert in Kubernetes. What about upgrades, right? If you try and do all at once, it's a bit of a problem. So it's a little bit tricky. You have to do it incrementally, because multiple teams are sharing the cluster. They might not be ready to accept the change. And then same with the Capsule. Capsule has the same thing. What about the other side, right? You can upgrade each cluster incrementally, right? You can go to the virtual cluster inside that's running the cluster and upgrade it one by one by one. That's good. That works. And same with individual. So this is the comparison, right? In front of you. You see the comparison. Now, I can't tell you which option is best for you. That depends on your use case. But it's important to understand that you have choices. We presented to you today, I presented to you 4 different choices. But of course, and you can understand what the implications of one or the other are, and then you can, make a guess or make an informed decision as to which one is good for you. But of course, I can't leave you just at that. Let's look at what's happening in the industry, and then we'll finish up. So we have another Adventa. We have another podcast where Theobald and Miguel talked about they had 4,000 engineers and they had about 30 clusters, 4 regions across. And what they noticed is that the ARM nodes were cheaper than the Intel nodes. So what they wanted to do is they wanted to work with the development team, right? They wanted to work with the development team and help them migrate to the ARM nodes, because you have to change the containers and all that stuff and smoothly migrate them. So what the platform team did, they worked with all the development teams and worked with them, and basically they migrated things over time, right? So just to make sure, they added nodes slowly, new nodes got added, some teams migrated over time. And so the teams could opt in and gradually do this. But what they did was, so this is one way of doing it, right? So you can, if you wanted to get teams to follow your standard, you can work with them and get them to, you can basically become a consultant with them. But what they did, which I liked, is they made the developers responsible for their service costs. Because the ARM nodes were cheaper, then people were incentivized to reduce the cost. So that's I kind of like that. Also at Mercari, we had Kensi, who talked about this. This is pretty cool. It's a Japanese marketplace, Mercari. So what they had is 1,000 microservices running in the cluster, and you have to define the requests and limits of the cluster, right? But developers usually would define. Imagine your pod requires only a bit of memory and CPU. They might define massive requests and limits, right? So it's not following good practices, not following best practices. So it's important that we increase and decrease the number of requests and limits that are assigned to it. Well, you can't really just, and you could end up with the pods are being underutilized. Basically, they're deployed on the node, and areas, a lot of space has been left free for that pod to be able to run. So that becomes a little bit of a problem. So what you can do is you can use what's known as a virtual pod autoscaler to adjust the memory requests over time. Adjust it over time. So this is what they did at Mercari. They said they wrote a tool called Tortoise. You can look it up online. Just type Tortoise GitHub or Tortoise Kubernetes. It comes up. They said what we're going to do is define our own controller that'll run in the cluster that will that will basically implement the horizontal and virtual pod autoscaler for the workloads that are running in the cluster. So over time, the tool itself will increase and decrease the size of the containers and how many containers they're running. And then you can define policies or whatever. So basically, the platform team provided a tool to drive down the cost. And the last one here, before we do a quick summary. So this is Getter, and Getter had a bunch of people that are working on there. It talked about, how to set the resources and limits correctly. But the important thing that Alexandre mentioned was that everything was driven from costs. Even in development, they wanted to keep the costs down. So you can use a bunch of tools to keep your costs down by keeping an eye on things. What is actually being how much is actually being used. There's a bunch of tools out there that help you with this costing. So there's things like Cube resource report that you can install in the cluster. There's Cube cost, there's Open cost. I'm not going to go into it, but you can check it out in your own time. There's Cast AI, there's Spot AI, and then there's like Optimize Live. Some of these also tell you what you can do to optimize your workloads. So what are the takeaways, right? Let's summarize. What we want from non-production environment is to have low cost, and we want to have low complexity, and we want to have high governance. And I showed you options here from left to right. We talked about the 4 options. And then these 4 options, we looked at what you can get in terms of cost and complexity. And the options are in front of you. You can see them right there. And the way we looked at how the other people have been implementing this, so there's some collaboration happening. The three ways you saw, there's collaboration happening between development and the platform team, and there's tooling being provided to scale up and down things when they're necessary. And then there's a bunch of just ownership to the developers. The developers do the ownership. So how can you do any of this stuff? Yeah, you have isolation. You make sure you have RBAC installed. You make sure you have resource quotas. Make sure you have security set up, and then also, optimize usage by using the tools correctly, and you do the scaling out and scaling in, and make the development teams responsible for the cost of running things and do governance itself on there. That is all I wanted to share. Quick couple of things. Next week, Simon and Mike are going to talk about ephemeral environments if you're interested in that. So Simon and Mike will talk about that next week. Do check in, do sign up for that. And then we have Chris Nesbitt. Oh, his images have disappeared. He's going to talk about what are the best practices for evolving your multi-tenancy approach as your organization grows, and how do you do the balance between security, performance, and operational complexity. So we'll go in a lot more detail in 2 weeks' time. All I want to say with that is thank you so much for listening. You can find me on Twitter and YouTube if you want. But I just want to thank you for listening. We might have time for answers, but do check out our website, learncase.io, if you're interested in some courses. And I just want to say thank you to all for dialing in and listening in, and also thanks to Mike and Loft for having us. That is it from me.
That's awesome. Yeah, you filled up so much time too. And it was like nice and consistent, and like I would end up talking like way too fast, like in 10 minutes. It was great. All right, let me go ahead and do our little outro real quick. Let me share my screen. All right, so here's what's coming up next week. So if you enjoyed this and you want to do a workshop next week that kind of covers some of the things that we're talking about here, join SIAM, and that's going to be March 20th at 8 a.m. So same place. Some new stuff, and then we also like Solomon said, we have another one coming up the next week too. So the next 2 weeks, next 2.5 weeks, I'll say, we have 3 more things coming up. So next week, join for this, and then you can go to the vcluster.com. They put it in the chat again too. The Multi-Tenancy March URL. Oh yeah. So here's a question. There's a question is, will the slides be made available? Solomon, I'm gonna
we can share the slides somehow. I don't know. We can, Mike, I'll share it with you. You can distribute it on Slack perhaps, or something like that. I don't know how you distribute it. We can share the slides, no issues.
So so join our Slack community and we can share stuff there. Just let us know. Slack.vcluster.com. If you want to schedule a demo, vcluster.com for enterprise demo. And then there's our thank you. But yeah, join us next week for this. If you missed anything and you want to rewatch it, it's gonna be on YouTube. Should be on StreamYard. It'll be on LinkedIn, and then I think the video save on Twitter and everything too. We didn't have a lot of questions, but I had one question.
Sure.
So like if I'm doing a dedicated cluster, you're saying, like, after listening, you're saying that production, like, I want very kind of small worker nodes, and I'm not running a lot of pods on it. Whereas with a developer, I'm probably having like really big worker nodes and like sharing and doing multi-tenancy. Was that?
Yeah, I mean, yeah, that's something. Is that something that you're thinking of doing? Like, you would have you could have a big, not a massive cluster, a cluster with multiple you can have different sizes of worker nodes, right? You can pick the different sizes of worker nodes, but you would usually have like a reasonable size cluster, so you can have multiple teams running on the cluster. So if I have a very small cluster, I only have 1 or 2 teams. Then that negates the point of me sharing the cluster. So you need to have a reasonable size cluster. I've seen like teams where people have clusters of, I'm going to say like 30 nodes, 40 nodes, things like that. But yeah, that's pretty much right, Mike.
Awesome. Yeah, I picked up on you're talking about like the worker node. You're talking about a workload. You're like, well, that's almost an entire worker node. I was like, wow, that's so small. So you're like, especially for ARM, right? Like you're running very small worker nodes, and you're only running a couple of
correct
pods there. All right, well, cool. Well, thank you so much. I know it's probably getting later there. We didn't have a ton of questions, but if you do have questions, post them on the comments on YouTube, post them on LinkedIn, post them on any of our social, and we should be able to reach out and answer those for you. Yeah, thanks everybody for joining us. We're hitting right around 9. Thank you so much, Solomon. Do you have anything else you want to say before we head out?
No, thank you all. Thank you so much. Thanks for having me, and thank you for having me, Mike. Appreciate it. Thanks for all tuning in.
Yep, appreciate it too. All right, see you all next time. See you next week. All right.
Cheers. Bye.